it's all equally impressive. You put tools in these people's hands, and what they do with them is just awesome. You know, you think you know an application, and next thing you know, there's 12 more that you didn't even think of.
Hello there, Internet, and welcome to the 3D Print Authority podcast. This is a place where we come together to have a transparent and no BS conversation about the world of 3D printing and technology. My name is Adam Fosnot. I'm a mechanical engineer, and I have been fascinated by 3D printing for as long as I can remember. Let's get started. All right. One thing that I'd like to start with, if you could just introduce yourself and Roboze to the audience.
Sure. So my name is Peter Rowland, and I am the North American Channel Director here at Roboze. My main responsibility is to build our reseller network and also our 3D parts fulfillment network in the US and Canada and Mexico. So Roboze is a high-end 3D printer OEM. Really, we specialize in advanced materials, the high-temp polymers such as PEEK, composites such as carbon PEEK and carbon PA, and really in the most extreme applications, really on the high end of the spectrum, not really that ubiquitous application field that you're probably used to seeing. We were started in 2015 by our founder in Italy, so we're an Italian company. Although we did move as of this year officially to Houston, Texas as well. So we have essentially HQ2 here in Houston, full-blown operations and machines operational as well. So it's really an impressive facility.
Awesome.
Nice big warehouse.
Awesome. I'm so excited to dive into kind of all of those things. But before we get there, could you introduce, kind of share something about yourself outside of your work with the audience so they can get to know you better?
There is nothing. No, I'm kidding. I think naturally one of the most interesting things about me is something I have no control over, because I'm not very inherently interesting at them. But something most people don't know is I was actually born in Anchorage, Alaska.
Okay.
So you could say that you know somebody from Anchorage, Alaska, from Alaska in general.
You know, I don't think I've ever met someone from Alaska, so this is a first for me.
That's it. AK. I wish I could tell you that I remember it, but I wasn't really good at paying attention back then. I was about a year old. But besides that, you know, I'm married. I have two beautiful daughters. I live in Connecticut.
Okay.
That's where I'm calling from now. And besides that, yeah, just staying active, you know, being outside, hiking, running, things like that.
Okay.
Pretty mundane.
Pretty mundane. I like hiking too. It's really nice, and I don't know how Connecticut is, but I know in New York we have the Adirondacks, which are just beautiful in so many places to explore up there.
So we get a nice swatch of the Appalachian Trail comes through here on the New York border.
Okay.
Which is just gorgeous, you know. And my brother and I have taken pieces of it away. You know, we've tried to chip away at it. Sometimes 30 miles at a time, sometimes 10, depending on how motivated we are at the time.
Sure.
And what our hydration level is for the last 72 hours.
Definitely. So I was looking at your LinkedIn profile, and it seems like you have quite a history working with 3D printing and also the 3D design side of things. So if it's okay with you, I kind of wanted to start there.
Yeah.
Because I think there's a lot that, especially the hobby space, can learn from all of your experience.
It's a great starting point, and it's funny because where I started in 3D printing is very much not where I am now, right?
Okay.
And most of my experience actually is in the construction and architecture technology space.
Okay.
3D printing came about towards the end of that experience. I was lucky enough to be really at a company for a very long time, serving the technology sector of the construction industry, mostly with proprietary software. Services and things like that. And we got into 3D printing towards the end of that, placing equipment at architects' locations. And they were using it for, massing models and concept models, feasibility studies, form studies, planning, and then finally presentation models, certainly when it came down to their final presentation or their final iteration of the building. It's a pretty good combination because every building is technically a prototype, right? So you're going through so many different iterations, and just like most things, you have to convey your design intent in every way you can. 3D printing was a very good resource for doing so in a tactile way. But all the different things that I think you and I at this point now judge 3D printing on are just simply not important to architects, right? They just want to look nice. And I shouldn't diminish it. It's still very important that things are printed properly, and color is a factor at times. They also love things to be very bright white. Sometimes they don't care about the technology as much as the whiteness of it, especially when it's overlaid on top of existing conditions. So my first introduction was certainly on the hobby side, and then into the dimensions and things like that. We found then when we were able to place equipment, it became actually a bit of a profit center for some of these architects because they incorporate that in their deliverable as well. And I think the most exciting things that we've seen on the full-blown presentation model side is a combination of conventional model making and 3D printing components, even multiple technologies, FDM, PolyJet, all combined into one beautiful model to then submit. We've seen some really gorgeous models.
Gotcha. That's really cool. The architecture side of things is kind of an odd niche from what I've seen. I've printed some architecture models. And it's funny you bring up the color white because I've run into a handful of situations where a customer will get really picky about two different parts and they look exactly the same to me, but he's convinced that the white is different.
Yeah.
And it has to be fixed. It's so amusing to me.
It's true that these designs they're so passionate about them, and it's so difficult to represent their intent in any other way besides building it. So when you do have to settle for something else, they're pretty particular. Yeah.
Understandably. So you spent a long time. How long were you involved with kind of that architecture space, both on the software and moving into 3D printing?
Oh, so my whole career was really that.
Okay.
For 20 years easily, bid management software, again, equipment placement, 2D and 3D.
Okay.
Bid management software, plan rooms, virtual plan rooms. Towards the end of that part of my career, I was lucky enough to be in a technology leadership role where we could essentially kind of choose what we wanted to represent and what services we wanted to offer. So what we did was 3D printing, but also virtual reality and laser scanning, which is something still pretty passionate about today, and then software, 2D PDF manipulation and document storage and retrieval and construction management software type software. Yeah.
Okay, cool. So you kind of were exposed to a lot of different technologies all in the same vein of...
Yeah, we had service bureaus as well. So we were able to use, again, PolyJet, CJP, and certainly FDM.
Okay, cool. So then you've transitioned into a role at Roboze.
Well, prior to Roboze, I actually transitioned to a role at the largest reseller of the largest 3D printer OEM in the world. Bit of a competitor to CAD Dimensions, so you'd probably know them. Although through multiple acquisitions, the name changed.
Sure.
So that was my first main entry point into the pure 3D printing world, right? On the VAR side. So we were again, probably the largest at the end of the acquisition periods. We were the largest in the world at that point. So that was the bridge that connected me from that experience to Roboze.
Okay, gotcha. So
it was a couple of years in that setting.
Okay, working for the largest distributor of industrial level 3D printing equipment.
Correct.
Does that make sense?
That is. Yep.
Okay, gotcha.
Same thing CAD Dimensions did. Yeah.
Sure. So that got you more in depth with 3D
Right.
printing, and then you moved over to Roboze.
More in depth with 3D printing and also the manufacturing sector in general. There are a lot of parallels between the two industries. The passion, the talent, it's all so impressive. And the subsequent talent on the side of those who serve, right? On our side, still impressive. It's all equally impressive. You put tools in these people's hands, and what they do with them is just awesome. You know, you think you know an application, and next thing you know, there's 12 more that you didn't even think of.
Yeah, yeah. I can relate walking into a customer's building and there's just 3D printed fixtures everywhere,
Yeah.
with a ton of creativity and thought behind how they were designed and implemented. So during your experience at the distributor, one thing that was really eye opening for me was just how the buying process worked.
Yeah.
Um, so in the hobby space, you just go on Amazon. You just go directly to a
Yeah.
manufacturer's website, and you just buy when you want. You look at some reviews online, and you make an informed choice. If you
Low
want to,
risk. Yeah.
yes, if you want to buy an industrial 3D printer, what does that process look like?
Yeah, that's really where I felt the most comfortable, Adam. First being involved, and certainly I was in a leadership role, and I'm comfortable in a leadership role. So I do feel like with the immense talent I had around me, the actual subject matter was less important to
Okay.
be an expert at. Although that came, the leadership aspect and then the business acumen to solve the exact thing you just mentioned is really where I came from. I was in the buyer's seat for quite a while, working for
Okay.
a public company, director of operations. Managed 8 locations, but had to buy equipment for all these locations, move locations, and just make these decisions myself and with my team. So speaking that language is something I'm really comfortable with. And really, every place I've gone, from the last place to even here at Robo's, speaking the ROI language and developing pro formas to really make that buying decision easier is probably the most critical part. The technology is sound, right? It's almost the easy part to say, hey, look at this part. Does this solve your need? Yes, great. That doesn't mean they're going to buy tomorrow.
Mm-hmm.
That's the easy part. Now, I say it's easy because I didn't put the effort into developing the technology. I was lucky enough that Robo's already did that and did a great job at it. But what we have to do, the hard part, is making the business case.
Okay.
How many of these or things like this justify the cost of the equipment? So one of the things that Robo's that we're doing here is we understand that using PEEK, using carbon PEEK, carbon PA, these advanced materials maybe don't have daily applications, at least not as often as we would think. So we are developing a 3D parts fulfillment network as well, right? Digital supply chain, basically, of partners that have our equipment and that we feed basically this work because we know the market needs parts, not necessarily needs equipment and parts. So that's one way we're building the business case is just fulfilling orders and monitoring, right? And understanding how much use is happening and when does it make sense. Now with a clear historical record of the orders, hey, now it makes sense.
Hey there, it's Adam. If you're enjoying this video, could you go ahead and tap the like button? It's totally free for you, and through the magic of internet algorithms, it will help more people see the podcast. Thanks.
The other way is, again, that in-depth ROI analysis. We go through what your current cost is, including the time it takes, the time away from your conventional use of your equipment, labor, and even time to market. All these different factors. And we just plug them in. We plug them into a calculator and say, hey, this does make sense. This breaks even halfway through your depreciation. Or no, this doesn't make sense. We need 3 or 4 more applications to justify it, right? So these are the things we go through. To be honest, it's probably the most fun part of the dialogue I have, because that's the hardest thing in 3D printing is that everybody's interested.
Hmm.
And when you're in sales and in a sales leadership role, and you're trying to get your teams to, get to the next step, typically interest is a hurdle you have to cross, right? But everybody's interested with 3D printing. It's just inherently interesting. Everyone wants more information. Everyone wants a price quote.
Okay.
Everyone wants to know what the speeds and feeds are, what the resolution is, And what happens is we kind of go through this involuntary checklist of this feature, that feature. But even if a certain solution doesn't meet the requirements or the criteria that you're discussing, or does, that doesn't mean a purchase will or will not happen. The financial justification has to be a part of the dialogue. It's a heavy
Gotcha.
emphasis of ours.
Okay. Cool. I
Could tell by my 10-minute answer that I like it a lot.
Yeah, no, I'm so happy that you went into kind of that level of detail because again, I think it's something that a lot of people don't understand.
Yeah,
Where again, if I'm buying a printer for my home because I want one, feeds, speeds, materials. When I say feeds and speeds, for anyone who doesn't know what we're talking about, how fast does the printer go? What's the diameter of the nozzle? What layer height can you print? Kind of all of those details are things that I'm probably going to look at and also look at price.
yeah,
But when a business is purchasing industrial equipment, it's a lot different. Where, from what you're saying, you're almost just plugging numbers into a spreadsheet and doing an analysis of what they're doing today versus what they could be doing with 3D printing.
right. And we certainly get to the technology. We get to the speeds. We get to the resolution. We get to the accuracy. So, some of the most exciting things about our technology are those aspects. But we want to make sure that when we make those points and they're received, it also still makes business sense. We're not out here trying to impress people people don't buy things because they're impressed, right? We want to make sure that there's a combination of both. We can actually meet the need. We can actually meet the success criteria of the part, but we also have the financial justification. So it's definitely both. I feel like sometimes in 3D printing, because it's so amazing, right? It's just so interesting. There's such great things you can do. We tend to get lost in that dialogue, right? We tend to lead with parts. We tend to lead with, again, tech specs. Whereas I'd rather have a conversation about you, your company. What are you doing now? How's business, right? Did you achieve your goals? And if not, where'd you fall short?
Mm-hmm.
If it's labor, well, that makes the conversation about how long it takes to make a part a little more relevant, right?
Okay. And so when you look at Roboze, they started in Italy.
Yep.
And from what I can tell, um, having not used it personally, they make pretty good equipment, but they haven't really been growing in the United States, I guess, until just recently. Can you kind of speak to what it's like working for a company headquartered in Europe and what it's like to kind of be a part of bringing that company to the US?
It's exciting. It's definitely a big difference. Where I've come from, I'm used to having just a ton of staff, ton of resources, a ton of delegating ability. This is equally fulfilling because they get it, right? They don't have a fully formed idea, hey, just come here and execute our plan. They're extremely open minded, they're extremely versatile. And because we're pretty small and again, new in this market, we're able to be flexible, we're able to react a lot faster. And more importantly, and I think one of the main reasons why I came here, and by the way, I'm only here for less than 2 months.
Okay.
So I'm still, getting my legs under me. But we're able to focus so much on the application and on the industries that we feel we serve best. Aerospace, oil and gas, motorsports. We're not trying to be everything to everyone. We're not trying to be a solve all here. We know where we fit, and we know where peak is most applicable. We're not trying to fit peak into every scenario either, right? Those who use peak now, they know how difficult it is. They know how expensive it is. We know we can solve those problems, right? It's pretty rare in 3D printing that you can even begin to have a material to material cost discussion.
Okay.
That's typically not a part of our dialogue, right? In a conventional sense, you're never going to say an ABS part that's 3D printed is cheaper than an ABS part that's injection molded, right?
Right.
It's just never going to be something that you talk about. It's negligible. You
Mm-hmm.
talk about low volume, high customization. You talk about things that are not able to be manufactured because they're different geometries. You talk about other things, right?
Sure.
With Peak, you can talk about the material savings with
Can
confidence.
you?
You can, because it's so expensive, and when you buy a billet and half of it's or 80% on the ground, they're paying for all of that material, and it's expensive. So
Mm-hmm.
when we say that the waste factor of our parts is obviously because it's additive, not subtractive, is almost gone, that's a real dollar figure for them because it's a sunken cost at this point. Not to mention all of the awful things I've heard, even recently, that you have to do with Peak, such as using liquid nitrogen to stabilize it, before you machine it. it it's a pretty tough material to work with, right?
Okay.
So we can have these conversations in terms that I'm not typically used to when it comes to the material savings and when it comes to the value proposition of the actual part.
Okay. Gotcha. This is really interesting to me because this is the first time I'm hearing a material to material comparison when it comes to 3D printing. Um, so when people are trying to machine peak, can you speak to some of those challenges?
Well, again, the cost, but also because it's so difficult to work with, and the liquid nitrogen is meant to stabilize the temperature so that doesn't melt
Okay.
incorrectly based on the friction of the head and things like that. But again, like aluminum, like anything else, right? You're paying for the whole billet and you're not using it all.
Gotcha.
And it's just considered a sunken cost, and that's something that we could actually remove from the equation.
Right. And so you mentioned a few different industries: oil and gas, aerospace, automotive. Um, what are you doing for those industries? Is it prototypes? Is it low volume production? Is it fixtures? What does that look like?
It's low volume production. We're actually doing a lot of end use parts, for oil and gas in particular. We're
Okay.
actually doing some downhole applications, right? Things that actually are used because of the chemical resistance properties of PEEK. You can use it, actually in field. Brackets, gaskets. We do a lot of TPU as well on the
Okay.
gasket side. The aerospace applications. We also obviously work with Ultim, so that's certified for aerospace. Lexan, very strong material as well. So we have a lot of end use parts that we are able to do. Housings, certainly, for motorsports, tubes, polypropylene tubes as well, because of the high resistance to chemical and water.
Okay.
A lot of really really neat applications like that. We're doing something now, which we just had a phenomenal call about, and I just posted something actually just today with the University of Colorado for something called CubeSats. So very small
Okay.
satellites that are launched into space. In this case, it's the ionosphere, so just below space, and they're basically what they sound like. They're very small cube satellites. They're relatively inexpensive, and they're being launched in space to be used for monitoring electromagnetic waves and things like that, interference with lightning as it relates to antennas and radios and things like that. I'm not articulating the application well enough, but they're up there and they're monitoring things. So what we developed for them, or what we're in partnership developing for them in Peak, are the housings for the actual sensors at the end of the satellite. Now,
Okay.
so keep in mind what has to happen there, right? There's an extreme high temperature when the sun is when the Earth is in the sun part of the orbit, and then there's
Mm-hmm.
an extreme low temperature when it's on the other side, right? So that
Okay.
temperature deviation needs to be accounted for, and it has to have a material that could accommodate that. not to mention radiation and just the temperature to be in that part of the atmosphere.
Yeah. And so it sounds a lot like Peak is kind of your guys' main focus. Is that accurate? Do you have a question about 3D printing? If so, I would love to answer it. Feel free to leave any questions in the comments down below or go to 3dprintauthority.com/forms to submit your question. Thanks.
It is Peak and Carbon Peak, which is a composite. We certainly do work with Carbon PA as well,
Okay.
and your typical nylons and polypropylene again, ABS, functional nylon. It's just the engineering of these machines is so advanced. By all means, you could use it for those other materials, but it's just the engineering is meant for dealing with these harder to work with materials and the tolerances as well. When
Okay.
we say 10 micron tolerance, because of our patented beltless system, it's pretty impressive in additive manufacturing terminology. But when we speak to people who work with machine tools, they say, yeah, it better be 10 microns. We're not even having a conversation if it's not. So that's the level of engineering that we're dealing with, and it's certainly more conducive to the higher temp polymers.
Okay. You mentioned a beltless system.
Yep.
What's that all about? Because most FDM 3D printers do use belts.
Right. So one of the ways, one of the founding elements, actually, in 2015, when our founder and CEO Alessio invented this equipment, it was really based on that principle, the beltless, the rack and pinion gantry, for the purpose of just having a more industrial, stronger, and more accurate gantry, right? And right now, our flagship, which I was just in Houston and I had the pleasure of seeing in person. You've been around 3D printers, I'm sure, a ton. They move, right?
Yes.
FDM, they move. Adam, I'm telling you, these things don't budge. They
Really?
had to tell me that it was printing, and I didn't believe them. I had to go up and look at it.
Okay.
These things are completely bomb-proof, and it's intended, again, for the accuracy, for the removal of variation, to be able to work with these materials, because they're so, they're just temperamental. So you have to remove all variables that you can, and it's movement, it's vibration, it's the incoming pneumatics are perfectly dried through a filter, through silica, through all this other engineering. Even the filament itself is super dried. It's in a housing, a high temp filament dryer housing,
Okay.
because PEEK is susceptible prior to extrusion to absorbing moisture from the atmosphere, much like nylons, right? Much
Okay.
like the polyamides. So we have a system that heats the filament before it's extruded to the point where the molecules can separate just enough to allow the water to evacuate, and then the air system actually pushes that moisture that has been released into the center of the spool and then subsequently out. This is the level of detail that you have to deal with when you're working with PEEK. It's very, very temperamental.
Yeah. No, that's really really cool. I think filament moisture is one of those challenges that a lot of times you don't see in a press release, right? You can talk about like, oh, we just have this amazing material and it's super super strong. It's really stiff. We're sending it into space, but some of those technical challenges can get overlooked, and moisture is definitely one of them.
Yeah. Well, that's where we're at now in this industry, right? There was a beginning where, let's say, it's almost like a marathon runner, right? Like you just want to pass the finish line. You just want to qualify. You just want to be in the race. Well, we're at elite status now, where we're shaving seconds off of our pace time, right? We're dialing this in so specifically, where we're not just trying to finish the race, we're trying to win the race, right? And it takes those little tiny incremental improvements and that reduction of variation to be in that elite status. And the U curve that we currently see with PLA and ABS and things like that, that's just the pack. That's the middle of the pack. That's just people who weekend warriors like me, right? But when it comes to the elite end of it, that those advanced materials, you have to get to that point where you're dealing with so many little nuances of the process, or you'll have some failures.
Hmm. Yeah, I agree. We're at the point in the progression of FDM printing where PLA and ABS, anyone can do that at home, right?
Yeah.
Or if you're not doing it at home and you're doing it as a business, you can do it
Or
for
behind you on a podcast.
right, or right behind me
Is
while we're
is
talking.
is that conveyor belt system?
Yeah, so this is the Power Belt Zero.
Hmm.
I'm just running some prototype parts on it, for new products that I'm working on for Power
And
Belt
it's
3D.
infinity build, basically. It just keeps on going and keeps on moving.
Exactly.
It's pretty
So
clever.
we print at an angle, and so you can print things that are infinitely long as long as you kind of support them on the end. Um, so it's a unique take on 3D printing. I think a
And
lot
this is
like
something that you developed, Adam?
yes.
Very cool.
So I run Powerbelt 3D, and kind of starting the 3D Print Authority podcast is another project that I'm working on.
That's pretty neat.
So thanks. I like to think it gives me some credibility, right? Um, in this space. Um, Going back to the Roboze equipment, especially in Houston.
Yeah.
Are we talking like there's a machine in a warehouse somewhere, or is it a little bit more elaborate than that?
Oh,
And
it's a full blown showroom. Certainly we need to fill it. Uh, I did post some pictures, which I'll share with you as well.
Okay,
On a number of incoming units, but they're all sold and shipping out as well. But we're getting some new shipments in. So it's a full blown showroom. It's a huge, high ceiling, open warehouse. I should say demo floor, essentially.
sure.
Yeah, it's pretty impressive space, and again, the machines are impressive. They're enormous.
Okay,
I think more than a ton and a half. I want to say like 3,700 pounds.
okay,
Let's see, the external, yeah, it's 76, 56, 93. Like they're big.
okay.
They're big
What
machines.
what do the build volumes look like?
So the Argo 500 is our flagship, and
Okay,
that's 500 because it's 500 millimeters cube.
okay,
So about 20 by 20 by 20.
gotcha.
The Argo 350 millimeters, but it's by 300 by 300. So 350, 300, 300.
Okay,
The middle of the road production series, more of the office production series, is the Extreme line. So those are more in the 250 range, 250 millimeters.
okay. Um, so we've talked about machines, materials, kind of who Roboze is seeking to serve in those industries. But you mentioned a production network.
Yeah.
A lot of 3D printing companies also have 3D printing services that they run, but this sounds kind of like a different take.
It's similar. I think the main reason why it's different is because, again, we're not trying to be everything to everyone. We know what our focus is, and we know that the market is in need of parts, right? And so when we talk about the supply chain 4.0 dynamic, right, this distributed manufacturing network, it's for that purpose. It's to put parts in people's hands when they need them. It's to empower service bureaus that might be existing service bureaus to have, again, that extra echelon of material capabilities now.
Okay.
Again, typically stop maybe at Ultim. We're going from Ultim and above, basically, right? And also our end users too, to tap into the need that's around them. The point that we are really trying to drive home is to bring manufacturing closer to the point of use. Certainly, the closest you can get is having a machine in house, but
Right.
if we have strategic partners in certain areas that are close to where fulfillment needs to happen, that's good as well. We're really, I'm a big lean practitioner. Again, I come from the operations production background, the sales background as well, and this is lean on a macro scale. And I made that comment recently, so I'm plagiarizing myself a bit, but it is, when you think about lean methodology and you think about, downtime, the downtime acronym, transportation is one of the biggest wastes, and besides the physical waste, the time waste, also the carbon emissions, these are all things. We all certainly learned this lesson in the fragility of the supply chain last year, that we're trying to mitigate. Another element of that waste is inventory, right? Having to inventory parts in a physical capacity. Instead, we're saying no, it should be digital inventory. You don't need to pay to store it. You don't need to pay for retrieval, production. It's inventoried in a digital way. You print as you go, right? It's on demand. You know, the waiting aspect of it as well. That's one of the biggest wastes that we saw last year too. And we're going to see it this year as well, where the supply chain is not going to recover as fast as all of us. So the demand is going to outgrow the supply. And now, when that happens, you're waiting. You're waiting for parts. You're waiting for, again, your existing supply chain. This brings that control back into your life, right? Whether it's in your facility or close to it. So it's not an incredibly unique concept as far as developing 3D parts fulfillment partners, but it is in our overall vision and our overall mission. And it certainly is predicated around that peak and carbon PA material, but not limited to that.
Right. You hit on a lot of really good points that I personally agree with in terms of redefining supply chain, being able to make parts on demand.
Yeah.
How do you get some of those concepts across to people who aren't as familiar with them, who are used to having a mold made halfway around the world and having plastic parts shipped into them?
Yeah. That's one of the biggest barriers to technology adoption is change management, right? I'm going to start first by saying our marketing team is outstanding.
Okay.
Really a big fan of our marketing team. And our application engineers as well, our technicians, our service techs, customer success managers, everybody in the whole chain, they're all phenomenal. And the reason why I'm saying that as an answer is the company culture is based around those concepts,
Okay.
not generic concepts, but very specific concepts, right? So that's ingrained in our messaging. It's not typical messaging. It's very specific. The white papers, our marketing content, the webinars we do. It's based on material. It's based on supply chain. So first, just getting the word out there, speaking in this language, being thought leaders in this space is important to us. And again, our CEO, his passion is contagious when it comes to this type of thing. It's really great to spend time with him, hear him speak to people, and obviously you're hearing it from me as well. I don't have a script, right? This is not something that is pre-planned. We believe these things. This is stuff that we weave into all of our dialogue because we believe it, and we feel like we can truly help advance manufacturing in this country and across the world, obviously. So that's one way, is to have it as a constant message. The other is, unfortunately, you have to experience the pain. That's going to drive a lot of things. So it's on us. It's on the sales team and the sales methodology. Again, not to just memorize text specs, but to dig in and to really ask, what challenges you experienced, and really uncover that pain, because there's no doubt that it happened. Something happened where there was a fault that you had no control over, and you want control. We're here to let you know that you actually can have control. You're not at the mercy of somebody else's mistakes. So those are some ways that we convey that message, and then
Gotcha.
monetizing it. Listen, at the end of the day, getting agreement doesn't mean much unless you could quantify it and say, hey, okay, you agree, you went through this. How much did it cost you? And it's tough. It's a tough conversation. It's not a, again, this is why I always tell the line between different leadership styles, but you're not intending to have a conversation that's always going to be really bright and cheery. You might be bringing up
Mhm.
some bad memories, but that's exactly how we make these messages real. Is what have you gone through, and what can we do to help you avoid going through that again?
Do you want to be a guest on this podcast? If so, go to 3dprintauthority.com/forms to apply. Thanks. Right. I think COVID really accelerated the distributed manufacturing
Yeah,
trends that we were looking at, where pretty much every company, Power Belt included, experienced supply chain issues
right.
where shipments were delayed, parts were not available, parts were too expensive, places had shut down. And so I think 3D printing is in a really good position to prevent issues like that from happening in the future.
I agree with that. I think if there's any silver lining for us, which I hate to even acknowledge any positive that could possibly come
Sure.
from the last awful year we had, but through the buzz around 3D printing has happened before, right? And at one point there was a B2C dynamic that was supposedly going to be something, and there was a huge bubble, and it ended up bursting, and you know it almost diminished the value of true 3D printing, right? While all that was happening, people that have been around 3D printing forever barely glanced over and then went back to work, right? Versus COVID, 3D printing really did help in a significant way, and really brought to light the value of literally making what you can't get from China or wherever else right there in your office. And in this case, it's critical. It's life saving. It's PPE. It's stuff that now it's real. It's not hobbyist type stuff. Now it's real. And so many people were involved, and I have to give so many OEMs credit, and folks like you and service bureaus and these different networks that exist now. Everybody stepped up. This is one thing I can say with confidence. There's not anybody I know in additive manufacturing that didn't step up and help. It was really, really great to see. But while that was happening, I do feel like there was a genuine approach to truly help. But the residual effect was everyone kind of paid attention to what was happening, right? All of a sudden, a real need was solved. It was pretty
Right.
exciting to see. And we
Yeah,
can build on that momentum.
I agree. Um, Before we wrap up, what is something outside of what you're doing at Roboze that you can kind of see, um, beyond some of the supply chain disruption that we've talked about, a trend, a technology, something you want to see more of within the 3D printing space?
I think I'm on two extreme ends of the spectrum here, Adam. On one end, good friend of mine, EJ, is involved with a company that does microfabrication.
Okay.
I mean, these things they print in such small, tiny little parts. It's almost not real, and it's so
Okay.
accurate, and it's so fascinating to understand what could be, down the line as far as the medical implications of things like that. And on the extreme other end, concrete 3D printing. Really,
Okay.
it's something I started obviously catching wind of in my past experience with construction and architecture, and thought, man, what a perfect combination and complement of those different worlds, where you truly have, you talk about, printing at the point of use. You're printing a building where it's actually going to be. I envision and can't wait for the time where I see a CSI code, which is a construction specification code. Right now, it exists for cast in place concrete and for precast. I can't wait until there's 3D printed CSI codes out there where it's so ubiquitous in the construction world that you 3D print components. I just think that stuff's fascinating, and obviously that evolving into space travel and 3D printing structures on the moon and on Mars, that kind of stuff just fascinates me.
Yeah, I agree. Those are two pretty far extremes
Yeah.
in terms of trends to look at. But I agree that both of them are really interesting. On the small side of things, in the microfabrication, 3D printing is usually regarded as pretty inaccurate by machining standards. Um, but when you get down to that scale, some of those concerns go away and things do become really accurate.
Yep.
And when you look at concrete, a lot of the precast ones have just insane tooling costs where to make precast concrete forms where 3D printing can absolutely revolutionize that space.
Even pre-printed components, yeah, and having more organic shapes and even without concrete, but just using 3D printing in construction, which again we tapped on a bit. There's a wonderful company out of Tennessee that's doing this now. They're building partition structures, the actual structural part of the partitions before they're filled, using robotic arms and again extruded polymers. And they're making these beautiful organic shapes, but they're just doing it in such an efficient way on site, on site with a track system. It's really, really fascinating.
Awesome. Peter, thank you so much for joining me today.
No, it was my pleasure.
Finally, where can people learn more about you, learn more about Roboze, and what you guys are trying to accomplish?
Yeah, I would invite everyone to visit roboze.com, Roboze. You'll see a lot of great information there. We're all over LinkedIn as well, so please visit our page. Feel free to connect with me too. I will say, again, I'm looking for resellers out there. We're looking for 3D parts partners. Come on board.
Awesome. Thanks, Peter.
Thank you.
Thank you so much for tuning in to listen or watch my chat with Peter from Roboze. Feel free to check out roboze.com to learn more about what they have to offer in terms of industrial level 3D printing equipment. If you haven't already, make sure to subscribe to 3D Print Authority wherever you might be watching or listening to this podcast, and visit 3dprintauthority.com to learn a little bit more about me and find the rest of the episodes of the podcast. Until next time, happy printing.